Hello, I'm Rafał and I'm from Poland, from Kraków. My talk is titled 5 Levels of High Availability from Multi-Instance to Hybrid Cloud. But first a few words about myself. I'm a team lead of the cloud native team at Hazelcast. Before I worked at Google and CERN, and I'm also an author of the book Continuous Delivery with Docker and Jenkins. And from time to time I do conference speaking and trainings, but on a daily basis I am an engineer. A few words about Hazelcast. So Hazelcast is a distributed company, it's an open source company, and we have 3 products. First is Hazelcast IMDG, which is in-memory data grid, used for caching or basically anything you would like to do in a distributed system. Hazelcast Jet is a library for stream processing, and Hazelcast Cloud, it is Hazelcast put as a service. Our agenda for this talk is pretty simple, so there will be a very short introduction about where we're going, about 5 high availability levels and why it's important and how it affects your system design. And then we will walk through these levels, and I will always mention like the trade-offs. What are the trade-offs? Why you should use them or why you should not use any of these levels. So let's start with the introduction. So in the beginning, and I mean in every system, like in the center of every system nowadays is a service. So every modern system architecture consists of services. Sometimes we call them microservices. Sometimes we call them microservices even though they are actually macroservices. But that doesn't matter. It doesn't matter if they are big or they are small. Well, they can even be the Lambda function. What matters is that this service is stateless. And stateless means stateless things are easy. I mean, we can replicate them, we can put wherever we want. Just imagine for a moment that everything you build is just a stateful service. So there are with no dependencies. Then it would be a paradise because like you can deploy the same calculator service on your laptop, on your production, on Kubernetes, on AWS, and everything works the same. So no problem. But coming back to life, that is not how the IT world looks like. So in the real life, each of these stateless services, it has dependencies to like a data store, to some queue, to some other services, or or basically anything, caching, everything that has a state. And in the context of high availability, data is the problem. So stateless things are not a problem, but the problem is the stateful part. That is why in this whole talk I will focus on the data part. I will always give you the full diagram and the full architecture. However, I will focus on the data part. With this introduction in mind, we can already start from the level 0, which means like we run everything on a single instance. And the diagram for this looks as follows. So we execute a request on our system, it goes to application service, which uses some stateful part located on the same machine. So perfect development environment. And you may think like, what kind of developer would even use something like that? However, it still makes some sense in some cases. Like if you build like an idempotent, like batch system for some processing which you can repeat, maybe it makes sense. What is good about the system? I did a small latency experiment and measured the latency of such scenarios. So if we have an application and in my case I measured this on Hazelcast, but it will be the same for databases, and measured like latency for read-write operation, and latency was it will not tell us anything. That was 80 milliseconds per 10,000 of entries. But when we compare it to other, it's just to compare it to other levels. So if you, what does it mean to you? If you create like everything on a single instance, It means that you are no highly available, no scalable. But from the good sides, it's like the access is very low latency. So there is no network involved, and data is always consistent. I mean, you cannot have inconsistent data if you have just one instance. But okay, you didn't come to this talk to listen of the single instance system. Then let's move right to high available systems. So running multi-instance means that we are running our software on multiple machines. So the definition would be, if one machine is down, the system is still available. And the diagram for this looks as follows. Request goes to load balancer, which is forwarded the traffic to application services, which are located in at least 2 machines. And then these application services, they use databases, which are located in at least 2 machines. So there is only one thing on this diagram that is like single, which is load balancer. But we will not focus so much on the load balancer part, because load balancer is kind of a solved problem. You can use some DNS-based load balancing or even some load balancer from cloud provider, which are super reliable. So we will not focus on load balancer. We'll also not focus on the stateless part, because that's the easy part. We'll focus on the data. So the assumption for multi-instance is we have local network, which is fast and reliable. Database is obviously located in at least 2 instances. For example, you can set up 2 EC2 instances and in the same high availability zone on AWS. So now we have like this 2, they are in the same data store. So usually this will be like, that's how the data store looks like. And the problem we have to solve here between these 2 instances of database is actually called data replication, meaning how to make the same data on 2 instances. And let me tell you here like a quick story about data replication, how it was done, how it is done now. So the first first way how we can do it, and it's done by most SQL databases, it was started this way, that application, they actually use one master replica on the data store. And now if this machine is down, then they fail over to the second machine. And in the meantime, every log event is replicated to the second instance, which is passive or read only, but not used for writes. Obviously, your masters can be sharded, slaves can be sharded, no problem with that. So that is how it all started. But recently, with the movement of NoSQL, people thought, okay, that is not good enough. This master writing only to master is not very performant. So we need something better. And there's something better is like implemented in most the NoSQL approaches. And how it looks like, your application, they don't use just one single master replica. They use the whole cluster, and the data inside the cluster is partitioned, and each instance stores some partitions of the data, and they are also stores some backup of the partitions of the data. And then if one machine is down, the backups are restored, so no problem at all. We don't lose data. So to give like maybe more specific example, I will show you how it looks like in Hazelcast. So Hazelcast is an in-memory data store, and it's key value, by the way. So it's like we split the keys into partitions, and each Hazelcast instance stores some partitions and stores some data partition backups. And now the rule here is that the data partition backup is always stored for the given partition, is always stored on another member, which makes sense. So that therefore, if one machine is down, one instance is down, we don't lose data. So for example, partition 1 is stored on the member 1 and its backup is stored on member 2, but it will never, we will never have a scenario when partition 1 is stored on member 1 and backup partition 1 is stored on member 1, because we need high availability. And that is more or less how all this NoSQL how they look like, how it all works. So this clustering strategy is like, obviously it's like objectively better solution, but it's hard to implement in relational databases, mainly because of the transactions requirements. Now the question is like, in both cases we have some backups. So should these backups be done synchronously or asynchronously? In other words, should we do synchronously and favor consistency, or should we do it asynchronously and favor latency? And would it be different for this SQL approach, master-slave replication, or for this clustering approach? So I did like another latency experiment and checked how it behaves. And I did like a synchronous backups and measured latency. And that is latency of read writes of Hazelcast with 4 members, and when the backups are done synchronously. So we will never have like inconsistency in data in the cluster itself. So we have like, it's much worse than single instance, which is maybe obvious, but it's still quite good. It's like, it's still 1 millisecond per entry, which is usually an acceptable latency, That is why in most of these cases, in most like there's NoSQL, you will see that by default the backups are done synchronously. So we favor the data consistency. Is it the same with the SQL approach and master-slave replication? Not necessarily. Like for example, MySQL by default, what they do is they do asynchronous backup, which means that, you know, in case of the failover, you may lose some data, but it's just a more complex operation, so they favor latency here. Short summary about setting up multi-instance of your data store in the same actually availability zone, so in the same local network. So what it means to you, if you set up your system this way, your data can still be consistent because the latency is usually still acceptable. Most tools support it, most cloud specific tools support it, and the setup is very simple even if you use on-premises data stores. One of the issue is that you have high latency because you set up your system in one local network. So if you access this from another networks or even another geographical regions, the latency will be high. Okay, we move to the one level higher, and now we will talk about multi-zone. Multi-zone means that if one availability zone is down, your system is still available. How it looks like on the diagram. So maybe before the diagram, that is actually the availability zone. This one is from Facebook, but basically availability zones by themselves, they are usually some data centers located not so far from each other, but they need to have an independent power supply and basically everything independent, so that if there is a power cut, then it affects only one availability zone. On the diagram, your system will look like this. So again, request goes to load balancer, it's forwarded to application services, which are located in at least 2 availability zones, and they use data store, which is located in at least 2 availability zones. So if you look at this diagram, it's actually quite similar to the diagram for multi-instance. So you may think, is there any actually, is my deployment any different than multi-instance? I would say like no, but also yes. So let me first tell you why no. So I did another latency experiment and set up, this time I've set up Hazelcast on 4 instances of Hazelcast, and 2 of them were located in one availability zone and 2 others were located in another availability zone. And measure here is the latency. Obviously it's slightly worse, but it's still not so much worse. It's not even twice that bad, and that is because when you have like availability zones in the cloud provider, they are always connected with a dedicated networking. So you know, it's not way slower. So in the terms of latency, you can use it. But I mentioned like there is some difference between your deployment for multi-zone comparing to multi-instance. And to explain it, let's look like an example. First, like maybe mention like what are the assumptions for our scenario. So we have machines in at least 2 availability zones, and the network is dedicated, so it's fast and reliable. For example, you can set up 2 EC2 instances in 2 AWS availability zone. Now, you remember this diagram. So I've seen like Hazelcast example of data partitions, data partition backups, etc. So you remember that the rule was here that the backup of the given partition is always stored in another member. However, it may happen, we may have a deployment like that. So we have some partition marked in yellow, and the backup of this partition is stored on another member 2, but they just happen to be in the same availability zone. Which means that if zone 1 is down, we lose the data. And that is definitely not something we would like to accept. That is why just using the same approach is not good enough. And we thought how to solve this problem in Hazelcast, and we came up with the idea of what we called a zone-aware feature. So we specify that in your Hazelcast configuration, I would like to have partition grouping, which takes into consideration the zone in which Hazelcast is deployed. But okay, like it's simpler said than done, because the zones, availability zones, are the concept of the environment. I mean, it's not the same in AWS, in Azure, in Kubernetes, so it's different. So then we came up with an idea of the plugins. So for each environment we have plugin, and which are automatically detected, so you don't even need to think about it. But they are also used for discovery, by the way. But then if you use Hazelcast on AWS, for example, it detects, okay, I'm running on AWS, so I use AWS plugin, and this AWS plugin, it uses AWS API to fetch the zone in which Hazelcast instance is located. And this way, if we are aware of the zone where the instance is located, we can say, okay, enable this zone aware, and say always store the partition backup in a different availability zone. And then if one zone is down, we don't lose the data. That is why I said no but yes, because you need to make sure that your data store supports zone aware feature. And don't take it for granted, because not every tool supports zone aware. So what does multi-zone mean to you? I would say that it's currently top 1 choice because you have very high availability, but you can still keep your data consistent. And consistency, it will be something we will use in the further levels. You can use a lot of cloud-specific toolkits. Again, like if your system is located in one region. So if it's accessed from another regions and you need high latency, it's not good enough for you. One level higher, it's multi-region. Multi-region means that if one region is down, the system is still available. How it looks like? So how it looks like the diagram for this. So usually a request goes to our system and it will go to a geo load balancer, which will take into the consideration your location so that it can forward the traffic to the right region. Then it goes to another load balancer, which is located inside the region. And then it's the same, goes to applications and goes to some data store. And in between the data stores, which are located in different regions, we have something called Geo Replication. So the assumption here is that we have machines in at least 2 geographical regions, and the network may be slow and unreliable. If you would like to try it on your own, you can set up EC2 instances in 2 regions, like let's say one in Europe, one in US. That's your scenario. Now you may think like, what is the big deal about like why a region is different than a zone? So let's take as an example like 2 regions for GCP. One can be Finland and another is Oregon. So the problem is that the physical distance, because 10,000 kilometers is a lot, and it happens that it's a lot not only for humans but also for light. Even if we take like a speed of light and check this distance, the round trip of the light in the vacuum would be itself, it would be 60 milliseconds, which is a lot. If it's not a vacuum, or if we take into consideration the fiber, it will be at least 3 times that, not counting the routers and all this in between. That is why we need something called Geo Replication. Geo Replication means we need to replicate the data across the regions. And Geo Replication is way different than the normal replication, because it must be asynchronous, because we cannot support like synchronous anymore, because it's just latency is too high. And your data store must support it, and you must be prepared for the data loss because we are asynchronous. Usually we operate in 2 modes. One is active-passive, the second one is active-active. Active-passive means that we use for writing only one cluster, and second one is not used, it can be used for read only. Then we replicate only one way. Then you must be prepared for the data loss because it's asynchronous, so you may store something in the cluster may be down at the same time and we don't have it replicated. And you must be prepared for the eventual consistency. In active mode is even worse, because you must be also prepared for the conflict resolution. Because what happens if you modify the same data at the same time in 2 clusters? You may have some strategy for conflict resolution, or you may give it to the user, to the like developer to decide what to do in such a scenario. In Hazelcast we have like a replication. Geo replication is called one replication, and it's very simple to set it up. So this is your configuration to use the geo replication. So very simple, but again it has some implication for you how to think about your system. But you may wonder like, but do I really need to lose the consistency? Is this 60 milliseconds for the light, is it such a big deal? And I did another latency experiment, and I checked just for the experiment what would happen if you would like to set up a consistent cluster with synchronous backup across multiple regions. And that was the result. So it's way more than multi-zone. It's really a lot, which means that you cannot use it. And the same with the geo replication, it would be the same as multi-zone because we do asynchronous replication. If you would like to have strong consistency or some distributed transactions, etc., you can read about new SQL like Spanner, CockroachDB, and multi-region distributed transactions, consensus algorithm, but it's always a trade-off between consistency and latency. We will not escape from that. So what does it mean like multi-region? What does it mean to you? So you are super highly available. You can have low latency access from any region. That is good. But you need to have geo replication, config resolution, and everything we mentioned. Okay, we go one step higher and we go multi-cloud. Multi-cloud means that if one cloud provider is down, your system is still available. How it looks like the diagram. So this is our diagram. So we first request goes to global load balancer. It load balances the traffic to one of the cloud providers. Inside each cloud provider, you usually will have another load balancer, applications, data, and geo replication in between. So you may ask, like, is it? So these are the assumptions. We have machines in like at least two cloud providers. You get the idea. So you may ask, like, is it really different than multi-region? Is it like, or is it the same? So there are some differences. So the first difference is that you cannot use cloud-specific toolkit if you would like to deploy exactly the same in different cloud providers. You don't have also VPC peering across cloud providers, so you need to use public network in between, which is not good in terms of latency and security. And obviously, if you would like to replicate your system across different cloud providers, the cost is way higher. But okay, like, is high availability the only reason for multi-cloud? And obviously, no, it's not even the main reason. So the main reason, from what we've seen like in Hazelcast, is why our customers choose to use multi-cloud solution is to avoid vendor lock-in. They would like to have better position in the cloud cost optimization and negotiation, because obviously, like, if there's a big company and if they go to the AWS and say, by the way, we are already deployed in Azure and GCP, can you make some discount for us? You're in a way better position in the negotiation. It's also about risk mitigation. It's also about low latency. If you'd like to, for example, the consumers of your service are deployed in different cloud providers and you would like to provide a very low latency, then you choose to go multi-cloud. So what it means to you, you have no vendor lock-in, you are in better position while negotiating the cloud cost, and you can provide low latency if accessed from multiple clouds. But the setup is way more complex and you cannot use cloud-specific toolkit, so you are on your own. You need to install on-premises software. The last level is hybrid cloud. So hybrid cloud means that if all cloud providers are down, your system is still available. But really, is it really possible that all cloud providers are down at the same time? Probably no, it's not possible. So high availability is not the reason for hybrid cloud. So the reason for hybrid cloud is main reason actually is some data regulations. For example, there are regulations in your country that the data of your customers must be stored inside your country or inside this building on your servers which are located here. So you need to have at least part of your infrastructure on premises. The other reason is data security, or you're just moving to cloud, so you keep the hybrid cloud solution as part of the process of moving to the cloud. Or you need some cost reduction. I mean, cloud providers are also expensive, so you need to sometimes maybe cheaper to have it on premises. How it looks like on the diagram. So again, you have global load balancer. You have your system deployed in different cloud providers, but also in your own premises, on your own servers on premises. And, it's like this it becomes very complex at this point. Even like multi-cloud, it becomes very complex to manage. So usually you will need some abstraction layer over your servers. And nowadays this abstraction layer will be Kubernetes or some derivatives of Kubernetes like OpenShift, IBM Cloud, or some of the implementation of the Kubernetes. Because otherwise otherwise it will be just too difficult to maintain your system in multiple cloud providers and on premises. So usually what people do nowadays is that deploy Kubernetes everywhere and then interact with every environment as it is an Kubernetes cluster. Short summary. So what it means to you if you go hybrid cloud, there is no vendor, no cloud lock-in. You have low latency of access from any custom network you want because you can set up your system wherever you want. But the setup is very complex, it's also very expensive, and you will need to go with some abstraction layer like Kubernetes. So that was the last level in terms of high availability. So as a short summary, I will try not to repeat anything I said before, but I would like to present to you a graph how I see different high availability levels comparing to the complexity and cost. So this is how I see it. So level 1 is super simple, there is no complexity involved at all. If we go from a single instance to multiple instances, we go from non-distributed system to a distributed system where we have data replication, so it becomes well more difficult. Going from multi-instance to multi-zone, it's actually not such a big step because we just need to make sure that our tools are zone aware and enable this. But now again, going from multi-zone to multi-region it is a big step because we go from a synchronous store to an asynchronous store because we need geo replication. Then going from multi-region to multi-cloud, it's another quite big step because we cannot use cloud portfolio if we would like to have homogeneous system. And then hybrid cloud means another big step because you need to have your own infrastructure. So now, which high availability level is for me? So I think if you don't know, then this is the best, this is the sweet spot because multi-zone is still quite easy to implement and operate, but it gives you very well, your system is very high available. If you are software cowboy, go with a single instance. Now multi-region I would choose if you need to go global with your system because of your latency or some other reasons. And multi-cloud and hybrid cloud, it's basically if you have some compliance, some requirements, regulations, then you will, all the banking industry, they go this way for that reasons. And with this last slide, I would like to thank you for listening to this talk. It was a pleasure to speak to you, and I hope you found it valuable. So thank you.